Very good morning. Should we start solving the problem? So, please write down the problem statement. We are going to solve a problem on worm and worm wheel design. A hoist is to be designed A hoist is to be designed to lift 20 kilonewton load at a velocity of 100 meter per minute. I'm repeating, hoist is to be designed to lift 20 kilonewton load at a velocity of 100 meters per minute if the diameter of the hoist drum is 600 mm and the power is to be transmitted to the drum shaft. Power is to be transmitted to the drum shaft from a 1440 RPM motor using worm and worm wheel. Select the suitable material of worm and the worm wheel and design the same. Select the material, design the worm and the worm wheel, find the power to be transmitted and the velocity ratio. So there is a motor which is driving a worm worm is driving a worm wheel, and on the wheel there is a hoist drum which is lifting a weight in a linear direction, and that weight is of 20 kilonewton. Can somebody draw the line diagram of this assembly? There is a motor and then there is a worm and worm wheel arrangement. And on the worm wheel shaft, there is another drum shaft. There is a motor whose rated power is not given, but it is rotating at 1440 RPM. This motor will drive the worm. This is the worm. Worm will drive the gear or the wheel. And there is another shaft which is the drum shaft mounted on the same shaft, or it's a drum mounted on the same shaft. Which is carrying a weight of 20 kilonewton. This linear speed, this is given as 100 meters per minute. In the side view, if you try to draw the same sketch, this is the worm. On the shaft, this is your gear. Here there is a drum shaft. And on this drum shaft, you have this wire rope which is lifting the weight of 20 kilonewton. Understanding this assembly is very important because, as I said, later we'll be designing the entire assembly. So this is the hoist drum. This is the worm. This is the worm gear or the wheel. In the side view. So what is the power required to lift 20 kilonewton load at 100 meter per minute? What would be the power required here? F into V. So this is 20 kilonewton into 100 meter per minute. If you convert this into per second, you will get the answer in kilowatt. Give me the answer. .3 kilowatt, you are right. Now this is the rated power or design power? This is the rated power. This is the actual power required, but we have to design it for a value little higher than this. So refer the design data book for worm and worm wheel. So if this is the rated power required here, what is the power for the motor? Or what is the design power for the motor? Into the service factor. Page number 175, design data book, BD Shivalkar, table 1615. What is the value of load factor? The value of load factor is given in table 11.5. This depends upon what is the input and the output shafts, and what is the application and what is the prime mover. Table 11.5 as per my design data book is on page number 112. Or the value of K, refer table 11.5. As per my data book, this is page number 112. So electric motor is driving a crane or an elevator with the value of K as 1.75. So what is the design power? Design power is 58.3. So what would be the next standard available motor? Next standard available motor, we pick up 60 kilowatt motor. So we are selecting a standard motor, 60 kilowatt power, running at 1440 RPM. This is given. This we have selected from our calculations. So what is the speed of the worm given as? Worm is mounted on the motor shaft. So what is the speed of the worm? What is the speed of the shaft which is carrying the worm? 1440. And what is the velocity of the gear? Ng. Now the velocity of the gear and the velocity of the drum, this might be different, but since the velocity of gear is not, the diameter of gear is not given, here we are assuming this diameter is same as that of the hoist diameter. Otherwise, we cannot find out what is the angular velocity or the linear velocity of the gear. So since due to lack of data, we are assuming the diameter of the gear drum is same as diameter of the hoist drum. And diameter of hoist drum is given as 600 mm with a linear velocity of 100 meters per minute. So you can calculate what is the angular velocity of the gear or the wheel. So with 100 meters per minute linear velocity, this is for the drum, the highest drum. This is pi into n into d. Diameter of the drum is given as 600 mm. So you are giving me the value of n. N of the drum is 53 watt units minus 53 RPM. It's 53.05. We'll take it 53 RPM. So whatever is the RPM of the drum, we are assuming this. So if you are assuming something, you are free to assume, but you must mention this. And so same is so what is the velocity ratio? What is the velocity ratio we are getting between the worm and the worm wheel? And is 7.1. Now refer the data book. For this velocity ratio, how many number of starts for the worm do we consider? Refer the design data book for worm and worm wheel. Table number 1616. Table 1616. For the velocity ratio 27, what is the number of starts given? It is 2. So it's a double start. So this happens to be number of teeth on the worm. And so what would be the number of teeth on the gear? Number of teeth on the gear would be velocity ratio times number of teeth on the worm. Ratio of their angular velocities is inversely proportional to ratio of their number of teeth. So it's 27 into 2. So number of teeth on the gear would be how much? 54 teeth. And now we start with the design of, as I said, for worm and worm wheel design, we don't design the worm, we only design the gear. We'll check if that is safe. We will refer to the design data book and we'll select the dimensions for the worm. So we start with design of this worm gear. Worm wheel or the worm gear. So assuming the module to be M in millimeters, diameter of the gear, the actual diameter is number of teeth times module M. Initially this was just an assumption to get a range of N. Now this is actual module times number of teeth, and so the pitch line velocity for the gear is pi dg ng by 1000. Give me the value in meter per second. dg use m times tg, ng let it be 53. So give me what is Vp in terms of m module. Give me the answer, Sambika. Vinay. Roll number 13, Vinay, you are there?
Yes, ma'am.
It's 0.14. Vinay, give me the answers. Why do we assume diameter of gear instead of velocity ratio? How would we assume velocity ratio? Either we should know the diameter of the gear or we should know the RPM of the gear. Now, nothing is known, and so initially to start with, we assume that the gear and the diameter of the drum is same. Gear diameter and drum diameter is same, so that we get an RPM for n. How can we assume velocity ratio? We have no idea. It could be anything from 10 to 100. So we assume this, the diameters. And now once we know the number of teeth and we are assuming module, so we now are taking the diameter of the gear wheel as m times tg. So this is now 0.15 times module. What is the next step? What is the next step? We find out what is the FT value, which is the design power upon Vp. You will get this as something by M. Give me the value. Design power, we have selected a motor of 60 kilowatt and Vp is 0.15. So what is Ft in terms of M? (400 kilonewtons). We convert this into Newton to avoid the calculation error later on upon M. This is in Newton. Next step. Bhavna Srinidhi, what is the next step? We select the material because now we want to find out what is the beam strength. FB is S0, Y, B, M and CB, for which we'll be taking the material properties first. So this is running at 1440 RPM, lifting 20 kilonewton weight. Although the service type is not given, but safely we can assume it to be a medium service. Since nothing is given, let us assume the service condition as medium. And for medium service condition, what is the material for the worm and the gear given in the data book? Table 1618. Give me the material properties. SA2320 steel for worm and for gear. Gear, as I said, will always use phosphor bronze. SA65. Phosphor bronze. Check for the material properties. For phosphor bronze, it is always 84 MPa. For phosphor bronze, the value of S0 is 84 MPa. Given on the table, the same table that we are referring for the gear material, since this is gear. Not for the worm, but for the gear. We don't design worm, we design it for the gear. So we are finding the beam strength for the gear tooth. For worm, the value of S0 is 350. That is okay. We have to assume, get the value of Y. Now Y would depend upon the pressure angle phi n. So what is the pressure angle? For pressure angle phi n, we need to know what is the value of lead angle lambda. And for the compact design, lambda is tan inverse of cube root of Ng by Nw as given in the design data book for compact design. Otherwise, the value is lead upon pi dw. Lead value is not known. So if that is not known, we use this Ng by Nw, which happens to be, this ratio is the velocity ratio 27. Take the cube root, take the tan inverse, given the value for lambda. Sarvesh, Karthik, give me the answers. Karthik, are you there? 18.4 degrees is lambda. And for this, what is the value of phi n? For lambda is 18.4 degrees. Table 1616 is giving the value of pressure angle. Pressure angle comes out to be 20 degrees. And now the value of y, the Lewis form factor is given as 0.314 plus 0.0151 phi n minus 14.5. Again given on table 1615. So we have to turn the pages, table 1615, table 1616, table 1617. It's 0.314 plus 0.015 pi n minus 14.5. Give me the value for y. Y comes out to be 0.39. Okay, we go with this value of y. So S0 is 84, y is 0.397. What about B? How do we take the value of B for gear? B is the face width. Now refer the table 1690. It is giving the value of face width B, table 1690, face width B for single and double thread and for triple and quadruple thread. Which one we are referring? Table 16, 19. How many threads we have taken for worm? Double thread. And so what is the formula for face width given for single and double thread? What is the formula for B? For gear. For gear, it is 2.38 times the circular pitch plus 6.25. What is circular pitch in terms of module? What is circular pitch in terms of module? Yes. Pi into m. Now this m is unknown. Here you have one more term in m. Here you will be getting something by m. And so this would be a complicated equation if I use this as 2.38 pi m plus 6.25. And hence for simplification, I am going to ignore this value 6.25 for time being. You know that we'll get the value of m, then we take the next higher available value. From that m, we again calculate what is b. So this is again giving us a range. So initially, we'll be considering b only as 2.38 pi m. Otherwise, you will be getting equation in m square, m cube, and m. Difficult to solve. And so the value of b is taken as 2.38 pi m into m. Now CV is given in terms of VP. VP is not known, and since the RPM of gear is less than 100 RPM, we will always use CV as 0.75 for gear, because gear will be rotating at low RPMs. Here the RPM of gear is 53. So this is 0.75. This we will equate with FT. So equating FT with FB, so you will get an equation in m square and 1 by m. And so m cube is something, so give me the value of m. Daitwa, give me the answer for m. Rajkumar, roll number 48. Are you with us? Roll number 48.
Yes, ma'am.
Give me the answer. Joel, roll number 50. Module is coming out to be 12.96. What is the next standard value available in the design data book? Joel, refer to design data book. Next value available from the preferred choice. 16. So we'll go with M16. Now with M16, give me the value of diameter of the gear. M times TG, give me the value of BP. Give me what is FT. The value of CV by calculation. Kajal, 51. DG is 864. Give me VP. 864, 868. 16 times TG. Velocity is 2.4. Give me the value of DG again. 54 M. M is 16. DG is 864. VP is 2.4. FT is how much? 25 kilonewton. What is CV? CV is 0.714. An assumed value was 0.75. Actual value is 0.714. Now we have to get the value for FD. Now the incremental load for FD or for the worm and worm wheel is not defined. So we'll be taking FD value directly as FB by CV. So it is actually FT by CV. The static load on CV, where CV is 0.714. So what is this FD coming out to be here? CV is to consider for the incremental load or the dynamic load. So what is FD? CV is 0.714. FT is 25 kilonewton. Give me FD. 35 exact. Okay. This is 35 kilonewton, which we'll be comparing with FB. Now for this FB, S0 is same, Y is same. Now while comparing, we ignore CV, M is same. Now you can use the actual value of B, which is 2.38 PC plus 6.25. With modulus 16, now you can use the value of B. Initially we ignored because it was difficult for us. Simplify. Give me value of B and give me FB. This FB should be greater than this FD. Then we say it is safe. $65.9. Others, please confirm the answer. Value for FB. With 65.9, FB is much higher than FD, and we say it is safe. 27271. Check it. 68, 67, 66. Okay. Please go ahead with your values. 67.166 Newton. So this is safe. So for worm and worm wheel, I am repeating the dynamic load is taken as static load upon CV, where CV is this calculated CV. And this value will directly compare with FB without CV. This is FB without CV. We don't have a formula defined for the incremental load. Then we check for FW quickly, which is the diameter for the gear, MTG into the value of B to K2 as per the formula given. For the limiting wear strength, value of K2, the load stress factor, is again given in table 16-17. For phosphor bronze, the value of K2 is given as 0.7. So this is MTG. B, you know, K2 is given as 0.7 in table 16-17 for the given material. Check that FW is greater than FD. Give me the wear strength. (76 kilonewton). 76 kilonewton. So the wear strength is greater than the dynamic load coming on the gear tooth. So we say this is safe. This completes half of the problem because we have done from the strength point of view. Now we have to design from heat generation point of view. From the heat generation point of view, depending upon the dimensions that we have selected, we have to find out what is the permissible rated power from the formula which we discussed in the last two class 3650, center distance raised to 1.7 upon velocity ratio plus 5. This is the rated power where the center distance C is to be taken in meters and you will get the value of power in kilowatt. Velocity ratio is just a ratio. How do you find C? If this is the worm with its diameter as dW, and if gear with dg, then this is the center distance. dg, I use current capital or small, whatever, dg plus dw by 2. What is the diameter of worm from the design data book? The design data book, what is dw? There are two options given. One is the pitch diameter of the worm. When the worm is bored in the shaft, which means the shaft is separate, worm is separate, and then we place a key. Or there is the worm which is integral with the shaft, which means they are manufactured as a single piece. So we can assume one of them. Let us say we are assuming the worm is bored for the shaft, which means shaft is separate. Worm is bored. Bored means it is hollow. So the formula is 2.4 circular pitch, which is pi m, plus 27.5. This is for single and double thread. Give me dw, value of dg, you know, give me the value of center distance. And from center distance in millimeters, convert this C in meters. Give me the value of rated power from the empirical relation. We have to make sure that this rated power is, this is the permissible rated power which a worm and worm wheel assembly with this much center distance and velocity ratio can permit. So this value should be higher than the rated motor that we are designing, from the rated motor power that we are designing. What is dW? $148. Okay, what is PR? Pratyusha, Vedant, give me the answers. Arshita, you are there? Rushika,
Yes, ma'am. Yes, ma'am.
give me the value for PR.
Yes, ma'am. Calculating. Ambika, what is 34.5? Okay, rated power is 35, 34.9. Okay, we go with 35. So if this rated power, as per the empirical formula, from heat generated point of view, if this is greater than the actual rated power of the motor, which is required for lifting a weight of 20 kilonewton at a given RPM, then this, from heat dissipation point of view, this is okay, or this is safe. What if this comes out to be less? Our actual rated power is 33.3 kilowatt. Suppose this comes out to be less than 30. If this is 28 kilowatt, what will you do? Manas? Manas, increase the dimensions? Yes. So how will you increase the value of C? By increasing dW and dG. And how would you increase dW? From looking at these formula. Increase the module. So if we increase the module, PC value would increase, dW would increase, similarly dG would increase. So if this rated power from heat generation point of view, this comes out to be less than the actual rated power, we increase the module. If this is greater than actual PR, this is safe. So explaining this point again, this formula is not given in the design data book, but we'll always start from here when we design it from heat generation point of view. For a given center distance and velocity ratio, for the worm and worm wheel pair to be safe, the rated power must come out to be greater than the actual power, which means this has a heat dissipation capacity for a rated power of 35 kilowatt. This is the meaning. So we have to always check that the rated power from the heat dissipation point of view from this empirical formula should come out to be greater than the actual rated power. So if this is done, quickly give me what is heat generated. This is 1 minus efficiency times the value of PR. Now here we are taking the actual value of PR. This was only to check. And for efficiency, we have to use the value for theta and lambda and mu. Design data book is giving the formula for efficiency, which we derived in other class. Mu cos theta minus mu tan lambda upon cos theta plus mu cot lambda.
Value of lambda, you know. For getting the value of mu, we have to first find out the value of rubbing velocity Vr, which is pi times dw nw cos lambda 1000. Get this value of Vr in meter per minute. From this Vr, give me the value of mu. Please complete this part and then we'll stop. Lambda value we have taken is 18. dw you know, nw you know. Give me Vr quickly, please. That's 706 meter per minute. And for this value of Vr, what is mu? If Vr is 704, what is mu? From the formula given in the data book, mu is 0.025 plus Vr taken in meter per minute upon 20,000, which comes out to be 0.06. Perfect. Now calculate theta. Theta depends upon phi n and lambda. Lambda, you know, phi n we have taken as 20 degrees. Give me theta quickly. And from theta, give me efficiency. We'll stop there. Shashwat, Harshil, Shriya, where are you? Shriya,
Yes, ma'am.
18 is theta.
Yes, I'm calculating.
Give me efficiency now. Sushmita, no answers from you today. 82% is efficiency. It's already 10:55. Should we stop or should we complete this part? Give me Hg. Give me the heat dissipated, which is K into area into rise in temperature. So what we'll do is we'll assume Hg is equal to Hd and we'll find out what is the rise in temperature. Efficiency, you know, PR is actual PR, 33.3 kilowatt you will be considering. Value of K is given in the data book. This is 0.4, 10 raised to minus 3 watt per mm square. We'll find out what is del T and we'll see that this is not crossing 60 degrees. The projected area for the heat dissipation, the area which is responsible for heat dissipation is this area. This is the worm and this is the V. This is the length of the worm given in the data book. This is the diameter of the worm. This is dg. So it is this complete area which is responsible for heat dissipation, and so this is LW into DW plus pi by 4 dg square. So that completes the problem. So if you have immediately a class next to this, you can leave this meeting. Next class will solve this part. If you are done, you can give me the answer. Otherwise, you are free to leave. Hello?